Ahoy! We're back. Part 2, trig functions, miscellaneous. So again, we're trying to make connections. This video is all about making connections, and we're going to hopefully do that in this video. But now, in the part 1, we kind of made a lot of connections about the unit circle and x and y and sine and cosine. Now we want to start making some connections with triangles. So here's the first problem that we're going to look at. Notice we have a beautiful right triangle here. We have a side marked 6, a side marked x, a side that isn't marked at all, and then we have an angle marked theta. All right, so we want to write an equation for x in terms of theta. Then we want to write an equation for theta in terms of x. Then we want to find the hypotenuse, and then we want to find a second equation for theta in terms of x. Holy cow, a lot going on here. All right, so let's go slow. First part says write an equation for x in terms of theta. So if I'm looking at this equation, the first thing I see is that I could build an equation pretty easily using tangent. I'm looking for the opposite side, x. The question clearly wanted me to involve x. I know the adjacent side is 6, and the angle here is theta. So I know that tangent of the angle theta equals opposite x over adjacent 6. And it says write an equation for x in terms of theta. So I want to write an equation for x, which means I want to know what does x equal. So I'm going to simply multiply both sides by 6, and I get x equals 6 times tangent of theta. So, oh, that's an ugly theta, but you see it. Anyway, so here is my equation for x in terms of theta. So again, if you whisper into my ear, theta is 23 degrees, well, then I can plug in 23 degrees and do 6 times tangent 23 degrees, and I'll figure out what x is. Or if you whisper into my ear, theta is 13 degrees. Well, then I can plug 13 degrees in, and I can do 6 times tangent of 13 degrees, and I'll get my answer. Pretty easy, pretty cool, pretty simple. Now they want me to write an equation for theta. So this time I want to know what theta equals. So once again, let's start with the fact that tangent of theta equals x over 6. But this time I want an equation for theta. So I need to solve this for theta. What do I do? How do I solve this for theta? I need to pull the old, well, that's a bad whistle. Even worse. I need to pull the old switcheroo. So I'm going to switch my input with my output. I'm going to switch the theta with the x over 6, but I have to use an inverse tangent. There's my opposite over adjacent inside, and now my output is the angle. Voila. There it is. There's an equation for theta in terms of x. So if a birdie lands on my shoulder and whispers, x is 7, I could do an inverse tangent of 7 over 6, and I could figure out what theta is. Or if another bird lands on my other shoulder and whispers, x is 20, well, then I could use my calculator, inverse tangent of 20 over 6, and I could solve for what theta is. Pretty cool. All right, now I got the first 2 parts done. Now they want me to find the hypotenuse. Okay, well, first, I don't know this side. So what that means is that I'm not going to be able to find a specific numerical value for the hypotenuse. Since one of my sides is unknown, then that means the hypotenuse is going to end up being unknown as well. But it doesn't mean I can't solve for what it would be in terms of x. So I just have to once again use the Pythagorean theorem. 6 squared plus x squared equals, I'll use an h for the hypotenuse squared. Just Pythagorean theorem. So that's 36 plus x squared equals h squared. Take the square root of both sides, and h equals the square root of 36 plus x squared. All right, let's talk about a couple things. One, anytime you take a square root, you do got to consider plus or minus, but it's a triangle. It's a side length. Can't be negative. Come on. And I can't tell you how many kids want to say, oh, the square root of 36 is 6. The square root of x squared is x. Oh, does that mean that it's 6 plus x? No. Come on. There's no rule in algebra. There is no rule in algebra that allows us to break apart a square root through a plus sign. So I'm sorry. The hypotenuse is the square root of 36 plus x squared. I don't care how badly you want to write 6 plus x. It doesn't work. And if you need me to prove why, I'm going to have to do it later because I don't have time to prove a simple algebra idea. So there is my hypotenuse. So now it says find a second equation for theta. Well, I already found one equation for theta. And the only way I could find a second equation is if I use another side, because I've already used the 6 and the x, which is tangent. If I'm going to use sine or cosine, I'm going to have to involve the hypotenuse. But no big deal. I have the hypotenuse now. So let's do sine. Sine of theta equals opposite x over hypotenuse, the square root of 36 plus x squared. Okay, not the prettiest, but it doesn't matter. And to solve for theta, because I wrote an equation for theta, I'm going to have to pull the old switcheroo, switching my input and my output. So sine inverse of x over the square root of 36 plus x squared equals theta. There you go. So kind of like this equation right here, if a bird lands on my shoulder and whispers x is 10, I could plug in inverse tangent of 10 over 6. But now I have another formula that can do it as well. I would plug in the inverse sine of 10 divided by the square root of 136, because x squared is 100. If x is 10, 10 squared is 100. 36 plus 100 is 136. So again, I would type in the inverse sine of 10 over the square root of 136. And, I encourage you to take a calculator right now and, prove that those are the same. I mean, seriously, it would be well worth your time to use a calculator, make sure you're in degree mode, and do tangent of 10 over 6, inverse tangent. I'm going to tell you right now, you get about 59 degrees. Do an inverse sine of 10 over the square root of 136, and you also get about 59 degrees. I'm telling you, it's the same thing. So that's what the angle would be. So again, I did it. I found another equation for theta that is different than the first one I found. And there's actually a third option. You could do cosine. Cosine of theta equals adjacent 6 over hypotenuse, square root of 36 plus x squared. Pull the old switcheroo. Theta equals the inverse cosine of 6 over the square root of 36 plus x squared. And you would have yourselves another answer. So hopefully this is a really cool problem. And the funny thing is I only know one side of the triangle. I literally don't know anything else in the problem. And I was still able to really do a lot with it. So pretty cool, right? Functions, inputs, outputs. That's what all of these are right now. They're functions. There's inputs, there's outputs. And you need to understand all of it. Pretty simple, I hope. All right, let's start a line of compositions. So these are tougher problems, but hopefully at the end of this you'll understand. These are trig functions within trig functions. Oh my gosh. So imagine plugging a trig function into another trig function. All right, let's start it off because these can be tricky. All right, write an algebraic expression that represents this. So I want to write an algebraic expression that represents this. Ugh, what is this? Oh my gosh. Well, okay. First off, I have to understand that the overall function is secant. So I need to find the answer to a secant. And remember, secant, according to a triangle, is the hypotenuse over the adjacent. So that's helpful. In terms of the unit circle, secant is the r divided by the x. You could do it that way as well. But that's going to be a little bit trickier to do it that way. I'd recommend thinking about triangles. Remember, this second part of this miscellaneous video is all about making connections with triangles. So what do I do? What do I do? How do I find the opposite or the hypotenuse? How do I find the adjacent? Because just writing words isn't going to get me my answer. An algebraic expression involves numbers and adding and plus and square roots and variables. I mean, it's, words is not algebraic. So, well, let's go to the inside. On the inside, I see an arc sine. Now remember, an arc sine is an angle. It's a sine inverse. It's an angle. And again, if you prefer to write the sine inverse of x minus 1, that's fine. But this is an angle. And I don't know what that angle is, especially because I don't know what x is. But you know what I can do? I can draw a picture of it, right? Sine inverse is equal to an angle. The output of an inverse function is an angle. So I can draw a picture of it. I mean, not going to be able to draw a whole lot, but I could still do it. So here's a right triangle, and here's theta. Okay, so I drew a picture of theta. And remember, what's the input to a sine inverse? The input to an inverse sine, according to a triangle, is the opposite over the hypotenuse. So I could easily make x minus 1 a fraction by putting it over 1. So if the output is an angle that I just drew a picture of, and the input is the relationship between the opposite side and the hypotenuse. Oh my gosh, I just drew it. There's my picture, right? I mean, truly understand this picture. If I look at this picture, sine of theta equals the opposite, x minus 1, over the hypotenuse 1. And then I could pull the old switcheroo, and theta would equal the inverse sine of, well, just x minus 1. So I literally took this trigonomic idea, and I was able to draw a picture. How cool is this? So now I'm actually almost done, right? I mean, remember, I want to find secant. I want to find secant of this angle that I just drew a picture of, because that's ultimately what this is. Arc sine, inverse sine is an angle. I want to find secant of that angle. I drew the picture of the angle, and now I want to find secant, which is the adjacent and the hypotenuse. Well, I know the hypotenuse, so heck, I'm halfway there. The hypotenuse is 1. The only thing I got to figure out is what's the adjacent side. And this is just going to involve a little bit of algebra. So once again, I'm going to use Pythagorean's theorem. Let's call the adjacent side a, and let's solve for it. A squared plus x minus 1 squared equals the hypotenuse, 1 squared. A squared plus, I got to take x minus 1 and square it, so that's x squared plus, oh, not plus, sorry about that, minus 2x plus 1 equals 1. So far, so good. And again, I'm solving for a. So I'm going to subtract everything over. If I subtract this 1 over, they cancel out, make a 0. So I'm going to add the 2x over. I'm going to subtract the x squared over. And then I got to take the square root. So there I am. The adjacent side is the square root of 2x minus x squared. There it is. Now, it's not a nice, pretty answer. Oh, well, sorry. But when there's an x involved, there's going to be an x involved. So really take the moment to process what I just did there. I was able to draw a triangle from literally like almost nothing, it seemed like. Pretty cool. And then I was able to find the missing side. Now, it does involve an x, which is okay, because this side right here involves an x, so what are you going to do? But notice all I did was use Pythagorean's theorem. I did a squared plus x minus 1 squared equals hypotenuse squared, and then I just did the math and solved for a. Okay, so now here I go. The answer to the question was secant of an angle. Here's the angle. Secant is the adjacent side, secant is the hypotenuse, 1, divided by the adjacent side, which is 2x minus x squared under a square root. And there is your final answer. Now, I know traditionally we don't like square roots and denominators, but when there's algebra involved, meaning x's, they're totally fine. It's when there's a number, like a square root of 3 or a square root of 5, a solid number, we don't want them down there. But if it's an algebraic expression, totally fine. So there's your final answer. Really not that hard. I actually think it's kind of easy. It takes a lot of connecting. You got to really connect the dots. Highly encourage you to rewatch me do this problem if you need a better explanation or just to hear it again. Let's try another one here. All right, fill in the blank. Okay, fill in the blank. All right. On the left side, we have an inverse tangent. And again, if you prefer to use a little -1, inverse tangent of 9 over x equals the inverse sine of what? Well, an inverse tangent is an angle. An inverse sine is an angle. And I want these two angles to be equal because that's what an equal sign means. So, oh boy, well, let's see here. What is the input to an inverse tangent? The output's an angle, but the input is, in terms of a triangle, this right here, this input would represent the opposite divided by the adjacent in a triangle. And the inside, the input to an inverse sine, is the opposite divided by the hypotenuse. And if these angles are equal, then this opposite right here is the same as this opposite. So I actually know part of my answer. The numerator is 9, because that, again, these two angles are equal. That's what an equal sign means. They're the same. Inverses are angles, so these two angles are equal, which means if I'm thinking about this triangle, tangent is opposite over adjacent, sine is opposite over hypotenuse. Those opposites are the same, so that would be 9. So I'm halfway there. I just need to figure out the hypotenuse. So let me go ahead and draw a picture of this angle. Again, this is the beauty of the trigonometry is I don't know a whole lot here, but I can draw a picture of it. So here's my angle theta. The inside, the input to tangent, is the opposite, there it is, over the adjacent, there it is. So the only thing I need to find is this hypotenuse, because that's what I need for the input to sine inverse. The input of sine inverse, when it comes to triangles, is the opposite divided by the hypotenuse. And again, I already have the opposite, 9, so I just got to figure out that hypotenuse. So here I go. X squared plus 9 squared equals the hypotenuse squared. Classic Pythagorean theorem. X squared plus 81 equals h squared. Square root, square root. The square root of x squared plus 81. Don't you dare say x plus 9. It doesn't work that way. It's an algebra rule. Come on. Don't have to worry about the negative option because it's a triangle. So there it is. There's my hypotenuse. It's the square root of x squared plus 81. So now the input to the inverse side, what I need to fill the blank in with, is the opposite divided by the hypotenuse. That's going to be 9 divided by x squared plus 81. So there's my answer right there. Beautiful. Once again, a lot of kids will say, well, what's x? I don't understand. Well, I don't know what x is, but if a little bird landed on my shoulder and told me that x is 2, well, then I could plug it in and I could figure it out. In fact, if x is 2, I could figure out everything. This missing side would be 2. The inside of the square root would be the square root of 85. 2 squared is 4. 4 plus 81 is 85. So then I would know everything. But I don't know what x is. The little bird didn't land on my shoulder and tell me. So again, really walk through that problem. Let's do another one like this. These are fun. At least I think they're fun. All right, so here we go. Arc sine, it's an inverse sine, equals arc cosine. Again, that's an inverse cosine. So, okay, they're equal. An inverse sine is an angle. An inverse cosine is an angle. If these two angles are the same, well, then that means all their pieces and parts have to be the same. So, well, what's the input for an inverse sine? According to a triangle, the input is the opposite divided by the hypotenuse. And what's the input for an inverse cosine? The adjacent divided by the hypotenuse. So again, if these angles are the same, like it says they are with the equal sign, that means the hypotenuses are the same. So I actually already know half my answer. The denominator is going to be 6. Because if my hypotenuse is 6 according to the input for the sine, then that would be the same for the cosine. So the only thing I need to figure out is the adjacent side. So again, let's draw a picture. And I'm going to label this as my theta this time. It doesn't matter. So if this is my angle theta, the input to inverse sine is the opposite. So the opposite side over here is 36 minus x squared. And the hypotenuse is 6. So the only thing I have to figure out is what the heck is this adjacent side. So here I go. The square root of 36 minus x squared squared plus, let's call this missing side b. So b squared equals the hypotenuse squared. Okay. Well, this first one's easy because the square and square root cancel. So I just get 36 minus x squared plus b squared equals 36. Now I got to solve for the b, so I'm going to subtract 36 over, which cancels out, right? So I bring this 36 over, they're gone. I'm going to add the x squared over, so I get b squared equals x squared. Again, I added the x squared over, I subtracted the 36, which enabled it to turn to a 0. And then one last step to do is to take the square root of each side to solve for b, and oh my gosh, what's the square root of x squared? X. So my missing side is just x. So now the input to inverse cosine is the adjacent over the hypotenuse. So I now know the adjacent is x and the hypotenuse is 6. So there is my answer. Once again, the funny thing is I never found what the angle was, yet I know that these two angles are equal. I know that this theta is the same as this and this theta. They're all the same theta. But I don't know. Until a birdie lands on my shoulder and tells me what x is, I can't figure out what that angle is. But it's so cool that I could still get to the bottom of this problem, even though I don't know what theta is. All right, now those last two problems, actually 3 problems, all involved x. There was an unknown that we didn't know. Well, now we're going to look at problems where there is something that we do know. There is no x. There is no unknown. So all of these are actually going to have answers, which is kind of nice. So let's tackle these. All right, so my recommendation is to just honestly think. You got to use your brain. All right. So first off, the overall value that I'm trying to find is an arc sine. That's a sine inverse. The answer, the output to a sine inverse, is an angle. So my final answer is going to be an angle. It is worth noting that. Now, the input is sine of 3 pi. So, okay, well, sine of 3 pi. What is sine of 3 pi? Well, I could figure that out. All I got to do is use my unit circle. So I got to find 3 pi. Well, here's 1 pi. Here's 2 pi, so here's 3 pi, right? It's just coterminal. If you take 3 pi and you subtract 2 pi, you get pi. So pi and 3 pi are one and the same. So what is the sine value? Well, that is 0. The y coordinate at 3 pi is 0. So I'm going to replace sine of 3 pi with 0. So I get sine inverse of 0. Okay. Now, this is an angle. And this is an angle where the y coordinate is 0. Okay, so now I got to look back on my unit circle. Where do you see an angle where the y coordinate is 0? Well, I see it right here at 0 radians. The y coordinate is 0. And right here at pi radians, the y coordinate is 0. But remember, inverse sine, you're only allowed to look up to pi over 2, down to negative pi over 2. Not allowed to look over on the left side. So that means the only answer for this problem is 0 radians. Pretty easy. Let's try another one. All right, arc cosine. So my final answer is going to be an angle. All right, so the input is cosine of 7 pi over 2. So I guess I need to figure out what that is. So let's look at my unit circle. Here's 1 pi over 2. Here's 3 pi over 2. So this would be 5 pi over 2, and this would be 7 pi over 2. Now, if you're like, what? Just take 7 halves and subtract 4 halves. Why? Because I'm just finding the coterminal angle by subtracting a full circle. A full circle is 2 pi, so I'm subtracting 2. 7 halves minus 2, 7 halves minus 4 halves is 3 halves. So 3 halves pi is the same terminal spot as 7 halves pi. All right, and it said cosine of 7 halves pi. Cosine is the x-coordinate, okay, 0. So that's nice. So this is 0. So now I'm going to write cosine inverse of 0. Okay, this is really easy. All right, so now this right here is an input, and that is a value 0. That is an x-coordinate from the unit circle. And I need to figure out the angle that has an x-coordinate of 0. So where do you see an angle that has an x-coordinate of 0? Right here, I see an x-coordinate of 0, and right down here, I see an x-coordinate of 0. So which one do I give? Do I say pi over 2, or do I say 3 pi over 2? Well, remember, cosine inverse only allows you to look at the top from 0 to pi. So the only answer that you're allowed to give is pi over 2. So pi over 2 is my final answer. And of course, I told you in the very beginning, because I was looking at an arc cosine, this is going to be an angle. All right, this one's kind of in reverse, actually. So now I have a tangent here. So I'm going to end up looking for a y-coordinate divided by an x-coordinate, because that's what tangent is. But this inside is what's going to trick me up here. This inside is a tangent inverse. Remember, tangent inverse is an angle. So this is an angle. I got to figure out what angle it is. So I'm trying to find an angle where the y divided by the x is 25. I don't think I'm going to find them on my unit circle anywhere. I don't think if you find, of the beautiful points, I don't think I'm going to find anywhere where the y divided by the x is 25. Sorry, I just don't think it's going to happen. So I'm going to have to go to my calculator. So I'm going to go to my calculator. It does want exact answers, and that's okay. So I'm going to go ahead and put myself in radian mode, just because I've been giving answers here in radians. And inverse tangent of 25 is roughly approximately 1.53. Now you're like, well, Mr. Trick, that's not exact. Okay, I'll get there. Just give me a moment. All right, so let's see here. Well, why don't we just type this in? I mean, think about it, right? Like this right here, arc tangent is an angle. That angle, I just figured out by using my calculator, is roughly 1.53. But if instead of typing in 1.53, I just type in the inverse tangent of 25, then I'll get that exact value. So I'm actually going to go to my calculator, I'm going to type in tangent, and then in parentheses, inverse tangent of 25. And I get 25. So my answer is 25? Yes. Here's why. Remember, draw a picture. This right here is an angle. The inside is an angle. The best way to understand an angle is to draw a picture of it. Tangent by definition is opposite over adjacent. So 25 over 1. It's got to be, right? I mean, this right here, the input to an inverse tangent is y divided by x. So the only way I can view that as a fraction is 25 over 1. Now, do I need to find the hypotenuse? Well, sure. I mean, you can. It'd be 25 squared plus 1 squared equals the hypotenuse squared. But I don't need to find the hypotenuse. Why? Because the problem wanted me to find tangent. And now that I have a picture of my angle, tangent is the opposite divided by the adjacent. Well, if I'm looking at the picture, the opposite divided by the adjacent is 25 over 1. 25. There's my answer. Crazy. Crazy how that works. Hopefully you understand that. It takes a little bit of time, but hopefully you do. All right, let's take a look at these problems now. Again, similar problems. They do want us to find the exact values. Highly encourage triangles. I really do. All right, so this is an angle. I can't say that. I mean, how many times have I said in this video? Inverse trig functions are angles. So this is an angle theta. The best way to view and understand an angle is to draw a picture of it. So here it is. Here's angle theta. The input to an inverse tangent is the opposite divided by the adjacent. So 2 is 2 over 1. Now, the problem is I want cosine. The problem wants me to find cosine of this angle. Well, cosine of the angle is the adjacent divided by the hypotenuse. I know the adjacent is 1. I got to find the hypotenuse. That's so easy to do. 1 squared plus 2 squared equals hypotenuse squared. That's 1 plus 4 equals hypotenuse squared. That's 5 equals hypotenuse squared. Take a square root, take a square root. Boom, your hypotenuse is the square root of 5. So cosine of this angle, which is what they want me to find, I drew a picture of the angle. This enabled me to draw the picture. But now that I have that picture, cosine of theta is the adjacent divided by the hypotenuse. There's my answer. But of course, I'm going to get rid of that square root in the denominator. And my final answer is radical 5 over 5. How awesome is that? All right, let's do another one here. All right, here is an angle. Inverses are angles. It's an angle. Let me draw a picture of this angle to best understand it. There's my angle that I'm drawing. By definition, the input of a cosine inverse is the adjacent divided by the hypotenuse. So there's radical 5 and 5. And they want me to find sine. Well, there's my angle. Sine is opposite over adjacent. I already know the adjacent is radical 5. I need to find that opposite side. How do I do that? Well, a squared plus radical 5 squared equals 5 squared. Just using Pythagorean's theorem. A squared equals 5. A squared plus 5 equals 25. A squared equals 20. Hopefully you're following my math. Take the square root. Be careful, 20 is 4 times 5, so that's 2 radical 5. My missing side is 2 radical 5. Now, again, what did the question want? The question wanted me to find sine. Okay, this is easy. Sine of this angle is the opposite, 2 radical 5, divided by the hypotenuse, 5. There's my answer. I mean, come on. It's not that hard. All right, Last problem of the day. All right, here, let me give a different color, green. Here is an arc cosine. It's an angle. Let's draw a picture of this angle. Okay, here's theta. Drew a picture of it. And the input to cosine inverse is an adjacent divided by a hypotenuse. Now, I know you're like, what? You can't have a negative side. Honestly, you're right. I can't. It doesn't make any sense. But remember, yes, these represent triangles, but they also represent angles within the unit circle. And within a triangle, you can't have a negative side, but in a unit circle, you can. So I'm going to let it slide for right now. All right, now I do need to find this opposite side here because, again, the question wanted me to find sine. Sine is opposite over hypotenuse, so I already got the hypotenuse is 3. I just got to figure out what the heck that opposite side is. Okay, well, let's see here. Okay, well, -2 squared plus b squared equals 3 squared. Just using Pythagorean theorem. 4 plus b squared equals 9. B squared equals 5. Square root. B is the square root of 5. There's my missing side, the square root of 5. So now sine of this angle is very simple to find. Opposite radical 5 divided by -2. Boom, done, easy. Now, you might say, how do I know that the hypotenuse wasn't the negative? Well, because again, you could look at these problems. Like I've been solving all these problems by thinking about triangles, but you could also solve them by thinking about x, y, and r. So for example, on this problem right here, I could think, well, x is -2, r is 3, and I need to find y. So again, it's just a different strategy. Instead of using a triangle, we're using the x, y, r method. Remember, it's just a different way, a different perspective of trig functions. So again, we talk about the arced cosine, inverse cosines are angles, and that the input is the adjacent over the hypotenuse. But on the unit circle, or again, on a circle, not necessarily the unit circle, the input could also be looked at as the x divided by the radius. And when you solve for y, you're still going to get the square root of 5. And when you say I need to find sine, sine is y divided by the radius. Excuse me. I'm so sorry. Did I do this wrong? No, I did it right. Yeah, I did do it wrong. I'm so sorry. I didn't do it wrong. I did it right, but I wrote something wrong here. Sine is the opposite radical 5 divided by the hypotenuse of 3. Sorry. But even if I use the x, y, r method, the point is once you know x, y, and r, then you ask yourself, what's sine? Sine is y, radical 5, over r, 3. You're going to get the right answer every time. It's really simple. Okay, I know that was a lot. I know this is long, and I really didn't cover a lot of information, just did a lot of examples. But it's important that you see a lot of examples. That way you understand everything that's going on here, because these problems can be tricky. What I'm trying to train you to do is train to think. You've got to be a logical thinker to get these problems right. All right, good luck. We'll keep moving on.